Hi, today we're talking about CCM6 Summary Statistics. There's a lot of writing in this video, so please make sure you're ready to hit pause whenever you need a break or whenever you need to see the entire message so you can write down everything. Okay, we got a lot of vocabulary. First, let's talk about distribution. Distribution is the arrangement of values in a data set. Distribution can be skewed. That means it's asymmetrical, and it's dealing with frequency distribution. Symmetrical is exhibiting symmetry. The data is well proportioned, it's regular in form or in its arrangement. A gap is a break or opening in your data. A cluster is a group of things close together. Peak is being at the point of maximum frequency. Measures of center establish a central location in a data set. Measures of variability establish the degree of variability in the individual data values and their deviations from the center. We're going to talk more about those two in a minute. Press pause if you need to, just so you can copy these down. Okay, so let's look at an example or some situations. We have two measures of center when we're dealing with statistics, the mean and the median. So those two measurements help us decide where the middle data values are. It's a good summary for your data if you can calculate the mean and the median. So it measures the center point of your data. Measures of variability are range, IQR, which stands for interquartile range, and MAD, which stands for mean absolute deviation. Measures of variability measure how far apart your data is. So your data could be clustered close together, so it would have a low range, a low IQR, and a low MAD. Or your data could be very spread apart, giving you a high range, a high IQR, and a MAD. We have some extreme values sometimes in our data sets. Those are called the minimum, the maximum. But sometimes we have very, very far out extremes. We call those outliers. Those outliers will have an effect on these measures of center and the measures of variability. And then lastly, just a review of the different types of graphs that you see. We have histograms, box plots, and dot plots. Often we call those dot plots line plots. Okay, so let's look at some images. Here are some different types of distributions. You have a skewed distribution, which means all of your data is pulled to the left or to the right. Your normal distribution means you have a symmetrical shape. You have just as many data values on the left side of your graph than you do on the right. And a flat distribution is really just even all the way across. The distribution of a set of data shows the arrangement of data values. It can be described by its center, spread, and shape. Other words that we use to describe distributions are peak, gap, cluster, symmetrical, and skewed. So let's look at an example right now. Again, if you need to just pause the video so you can jot all this stuff down, feel free to do that. Okay, so here's an example of a line plot, also known as a dot plot. And we can use those vocabulary words we just went over to describe its distribution. The distribution below has a cluster of data values within the intervals 10 to 12. So here is the main focus of our data. It's a cluster. The gaps are at 9 and 13 because they have no data values at all. The value 10 here is a peak because it is the most frequently occurring value. And I would say that this distribution, its shape is very close to a normal shape because the data is not pushed all the way to the left or to the right. So it's pretty normal. It peaks and then comes back down. All right, So let's look at some more data and determine the distribution of that data. So we're going to use the vocab words to describe the distribution. What I have here are concert wait times. It looks like we've got wait times in increments of 10 minutes, so 0 to 9 minutes, 10 to 19 minutes, 20 to 29 minutes, and so on. So first thing I notice from my graph is that I have a huge gap. This gap is caused by an outlier, so I can go ahead and write down two of my solutions here. So my outlier is from 90 to 99 minutes. Somebody waited that long to go to the concert. The gap is from the last bar all the way to the outlier. So it's from 50 all the way to almost the start of the last bar. So all the way to 89. That's a very large gap for the situation. I can take a look at the peak and find the highest peak on my histogram, and that's from 20 to 29 minutes. And then we can look at the shape. Now, the options we had for shape were skewed, normal, and flat. If I ignore the outlier, then I have a pretty normal or symmetrical shape. So I'm just going to write that in my description here of shape. Normal if we ignore the outlier. All right, so I can use this information to kind of predict if I were attending this concert, what would happen to me. So I could expect to wait anywhere between 0 and 49 minutes for this concert. I would guess that the most popular time is between 20 and 29 minutes. So if I were going, I would say, oh yeah, we'll probably wait between 20 and 29 minutes to go into the concert. If I'm unlucky, then I might be that person that has to wait 90 to 99 minutes. So this is just a prediction model. I don't think that would happen, but it happened to somebody, so we have to represent it in the data here. So let's look at another situation that's not graphical. It says, based on the salaries below, which measure of center will be most accurate? So I've got two companies, it looks like, and then I've got salaries for employees of that company. Somebody makes $1.2 million, $242,000, $265,500, and then you can read the rest of them here. So looking at company A, if I obviously have an outlier, that's really going to affect my measure of center. Remember, my two measures of center were the mean and the median. This is really going to affect my mean. So if I were choosing a measure of center that best describes the data that most accurately, then I am not choosing the mean, because the mean, this large outlier would skew my mean. It would push it higher than what it realistically is. So for company A, the median is the best measure of center to use to describe the salaries of the employees in company A. I could guess the person that makes all that money is the CEO or the person in charge. So it's inaccurate to use his data as a summary for all of the employees of the company. In company B, looking at the data, this information is actually more together. It's not as spread out as company A. So for company B, I would actually say the median or the mean would be accurate measures of center. So we could say mean or median for company B. I'm going to let you go ahead and try these out on your own. Press pause, and then when you're ready, press play, and I'll show the answers on the screen. Okay, we have another graph here, and we're using these vocab words to describe the distribution. We're looking at solar eclipses between 2010, I'm sorry, that's 2001 to 2010, and it looks like down here we have times. 1 second to 2 minutes and 30 seconds, 2 minutes and 31 seconds to 5 minutes, 5 minutes and 1 second to 7 minutes and 30 seconds, 7 minutes 31 seconds to 10 minutes, and 10 minutes and 1 second to 12 minutes and 30 seconds. And just to review, this is called a histogram. So it looks like my shape here is skewed because most of the data is pushed to one side. It looks like that there's no gaps, so I can write none here. My cluster is hard to tell. I could justify that the cluster is between 1 second and 5 minutes. Or I can even go out and say the cluster is from so that's 1 second all the way out to 7 minutes and 30 seconds. The peak, which is the most frequent time of a solar eclipse, is 1 second through 2 minutes and 30 seconds. But if we had a solar eclipse, I would guess that it's going to range anywhere between 1 second and 7 minutes and 30 seconds, since that's where our cluster of data falls. Okay, in the next question below are the hourly rates at two competing stores. Based on the measures of center, where would you rather work? So remember, the measures of center are the mean and the median. So looking at this data at REI, I've got a really high outlier. So I would not use the mean to figure out the measure of center. I would use the median. That would be a more accurate representation of the salary or the hourly rates at REI versus Gander Mountain. The median for Gander Mountain is $9.50, which ends up being the higher one. And I know mode was not mentioned here as a measure of center, but that's the number that occurs the most, so you can also take that into consideration when you're just talking about measurements and summary statistics. But the median here is higher at Gander Mountain, and that's the one I would choose. The outlier of 24 for REI makes this mean unrealistic, so I would not use the mean. I would just focus on the medians. All right, well, I hope you got a grasp of summary statistics and how they're useful when looking at data. If you still have questions, don't forget to ask your teacher, and hopefully you guys did all right today. Have a good one.